Okay, I find our last lesson really interesting because it connects to something we were just talking about, which is nuclear power. So, nuclear power we talked about as a solution to climate change, emitting 10 to 100 times less carbon dioxide emissions than coal or natural gas would into the atmosphere, thereby reducing the greenhouse gas effect. However, it's not without its consequences. So, one of the consequences of nuclear power is the waste that is produced and the radiation that happens, and the potential for large scale nuclear fallout, or like, say, in Chernobyl, when we had a giant nuclear explosion. You can also connect this to the atomic bomb. There's lots of testing sites. I know, this is striking me a lot. Owen's comment about having nuclear atomic bomb testing in the United States. I was just reading about actually a incident of testing the atomic bomb, which is kind of a rabbit hole I'll go into at the end of the lesson, so you can follow me there. But I also just wanted to show that it connects a little bit to the consequences of our actions. Like, everything we do in the world right now has a consequence, maybe a benefit, but we also need to think about what those are. So this is coming from Jenna's comment about, towards the end of our lesson last week, about how to build nuclear warning signs. So some of you might recognize that trifold symbol, that it marks radiation. But they did this test, only 6% of people on the earth actually know that that means danger or radiation. And so when we start to lose a common language around a symbol, let's say in 10,000 years, who knows what society is going to look like then? How do we signal to people that the area is damaged and that it's toxic and radioactive to go there? So I think that's a pretty interesting connection. But let's learn about why radiation is so bad and how are astronauts actually going to be exposed to this radiation when they're up in space. All right, so here we go. Let's enter our lesson. Flashes of light. In the summer of 1969, the crew of the Apollo 11 launched into space with the hopes of landing on the moon. While they expected to see incredible sights of the Earth in outer space, they didn't anticipate the strange flashes of light they reportedly saw in their eyes. These strange flashes were also reported by astronauts on board the Shuttle, Skylab, and the International Space Station in the years that followed. So what's going on? Could these flashes of lights be harming astronauts? Could they prevent a successful mission to Mars? In this lesson, we'll find out. Here's the crew of the Apollo 11 mission. Oh, Apollo 7. Interesting. So, surrounded by radiation, scientists believe that these flashes of lights may be the cause of radiation. Some forms of radiation can be dangerous. Radioactivity is actually part of our everyday lives. The food we eat, the materials we use to build our homes and offices, even some of the elements in our own body contain naturally occurring radioactive elements. Take a look below to find out more about radiation in our everyday lives. Bananas. About 0.01% of the potassium in bananas contains K40, which is a radioactive form of potassium. Our bodies need potassium to function, but we will eliminate excess potassium, so don't worry, bananas are safe. Sunlight. Although sunlight can be beneficial for your skin, reactions on the sun can release large amounts of harmful radiation into outer space. Thankfully, the Earth's atmosphere protects us from that. So, thinking back to our last unit, the sun's atmosphere keeping it warm, but also protecting us from radiation. The issue when you have a hole in the ozone layer, right, that would lead to more rays coming in, and that would be bad for radiation, leading to skin cancer. Here we have cancer treatment. Radiation can be used to treat cancer. Radiation therapy can kill cancer cells by damaging the cell's DNA. And imagine that's for cancer cells, but imagine that also happens to your own cells. So cells that divide really fast, like your hair cells and your stomach lining. Oftentimes people who undergo radiation lose their hair, and they also have really bad, painful stomach problems. So what is radiation? Given that radiation is such a common part of our daily lives, we have to wonder, what is it exactly? According to the World Nuclear Association, radiation is simply energy traveling through space. Radiation can be divided into two groups: non-ionizing radiation, such as the energy transmitted through radio or microwaves. This type of radiation is less dangerous when in controlled doses compared to other types of radiation. Or ionizing radiation can be harmful to the human body. When ionizing radiation strikes the human body, it can give molecules a charge, positive or negative. That doesn't seem like a big deal, but it can cause significant changes to how those molecules function. Sort the following forms of radiation into the appropriate areas. And so before we go in that, I just wanted to make this bigger and show you guys this little diagram. But here we have what they say is safe and beneficial and appropriate dosages, ELF, VLF, and then LF. So these are frequencies that have longer wavelengths and longer frequencies. And ELF just stands for extremely low frequency radiation. Okay, and it might add to your background information to know that this radiation is both an electric field and a magnetic field. And the difference there is the electric field is the forces acting on the charged particles. So that's like electrons and protons, which cause them to move. And that's simply a flow of electrons. It can be measured in volts per meter or kilovolts. And magnetic field is the charged particles in motion. So it's the strength of the magnetic field. It can be measured in Teslas or Gauss. Okay. And so we start to get dangerous over here when the frequency picks up. And those ionizing radiation waves are able to interact. It's energy moving through space, so that energy moves to your DNA and actually like blasts it apart. Think of a bomb. It's a force against your DNA, oftentimes causing things like thymine dimers. Particularly this is from UV radiation, like from the sun, but it would cause two thymines to bond on one side of the DNA. So you can see how that would mess up a lot of different things. That would mess up things like replication, replicating DNA before cell division. And if that's messed up, that can lead to things like cancer. Okay, so the difference here between ionizing and non-ionizing is the ability to create an ion or a positive or negative charge. So those are the more intense rays, gamma rays and X-rays with a higher frequency. Lower frequency, like radio frequencies, microwaves, and then infrared radiation from an electric heater or remote control, or what we call non-ionizing. So you can't necessarily get radiation poisoning from non-ionizing radiation. You know, it's an interesting question. Some people are like, are microwaves not safe? But microwaves are using energy moving through space to heat your food. If you were to expose yourself to that, maybe over time, that like within the microwave, that would cause problems, but in and of itself, microwaving your food isn't necessarily bad. And there are some studies that show that if you microwave plastic, some of those plastic chemicals can leach into the food, but probably not at a great enough concentration to cause some effects for you. All right, those are so many different rabbit holes, but let's go down this one, the type of radiation in space. Could the strange flashes of light that caused the Apollo 11 astronauts witnessed be caused by radiation? We know that radiation is present on Earth, but is it present in outer space? Definitely. Take a look at two kinds of ionizing radiation in outer space. So we have solar energetic particles. When hot plasma crashes down on the sun's surface or is squirted into space, it can cause a solar flare or a coronal mass ejection, respectively. Both of these events send huge amounts of radiation into outer space. Okay, the other type being galactic cosmic radiation. Radiation can also come from areas outside of our own solar system. This radiation from exploding stars far beyond is called galactic cosmic radiation. Sort the additional 2 forms of radiation into the appropriate category. Okay, and they just set up here that these are ionizing radiation, so let's go ahead and put them under the ionizing radiation category. Both galactic cosmic radiation and solar energetic particles are forms of ionizing radiation. How might encountering these forms of radiation on your mission affect the safety of your crew? Is it that this type of radiation can be harmful since ionizing radiation can damage cells? That sounds about right. This type of radiation is harmless. This type of radiation will boost the health, or will it boost antibiotics? None of those are true. It is harmful. And this is actually a radiation dosimeter, so basically it measures your radiation exposure. It's pretty neat. To have a lot of people who work as radiologists will wear one of those so that they can measure their level of radiation. I had a friend who was a rad tech is what they called themselves, but she had to wear one of those. So what could these health effects be on astronauts? Turns out the flashes of light experiences by the crew of the Apollo were high energy particles, or radiation. These flashes of light struck the eye's retina and stimulated them so they produced the appearance of light. Though these flashes may seem insignificant, the effects of the radiation that caused them may be far more severe. So here we have acute effects. The immediate effects of radiation depend on the dose of the radiation received. This may lead to mild effects such as feeling nauseous or vomiting, or more serious effects such as central nervous system damage. It can possibly even cause death. And then chronic, so acute would be like one particular time. Chronic would be over a long period of time. Some of the longer effect of space flight can include developing cataracts, which can cause blurry vision or cancer. This is why an astronaut with personal or family history of cancer may be an unwise choice for your mission, because you're adding a stress onto something that they're already predisposed of. Based on what you know about radiation, rank how important you think combating it will be for a mission to Mars. Well, they're going to be up in space, so I think that's probably pretty important. All right, so the dangers of space radiation. Although the dangers of ionizing radiation in space are clear, protecting your crew from such radiation may prove to be a challenge. Solar energetic particles. The high energy particles from solar events can travel extremely quickly, reaching Earth in a matter of 30 minutes. This speed makes it hard for astronauts in space to predict and prepare for such events. Galactic cosmic radiation. Most of the radiation affecting your crew will be in this form. Typically, this radiation can pass through spacecrafts and the skin of astronauts. Shielding against this type of radiation and these particles is difficult. Given this new information, would you change your ranking? If so, how? Okay, and it's interesting just to take a look at this. How much cosmic radiation comes to the sea? How much the US annual average, I'm assuming this is per person maybe, in the unit here is millisieverts. And then I don't know quite why this is about, but it seems like you have the same exposure on a 180-day transit as you do on a 500-day transit. So you can see here how there is a huge, and this is logarithmic, so this is increasing by a scale of 10 each time, a ton more radiation if you go out into space than at sea level on Earth. All right, so how are we going to protect ourselves, our astronauts? For humans on Earth, the effects of space radiation is minimal. This is because the Earth's magnetic field deflects most radiation. For astronauts in space, however, an effective solution has yet to be found. There is currently no shielding for harmful galactic cosmic radiation. However, some space agencies have taken the following preventative measures. Schedule spacewalks during low solar activity. Have astronauts wear dosimeters, which measure radiation. Equip spaceships with a safe haven or shelter to move to during solar storms. Or build spacecrafts with material that can shield some radiation. Based on these preventative measures, what features would you look for in a Mars-bound spacecraft? So I would think you would write something along the lines of having materials and then creating a space haven, and then also having a dosimeter. All right, and to wrap up here, how well do you think you understand this topic? Go ahead and answer that, and we'll summarize here. Reflect on what you've learned so far. Choose a spacecraft that is equipped with shielding to protect your crew from radiation. Remember, you may not need to know about all the equipment on board a particular spacecraft. Try to make your best choice given the information you do have. To select a spacecraft, open up My Mission app in the upper right-hand corner. Then select Spacecraft. Okay, so let's open up our mission. All right, what do we want? Do we want the Zenith 1 with radiation shielding panels? That seems cool. Extra vehicle mobility unit, water recovery system, oral saline solutions. The Celestial Voyager has a EVH. Fluorocortisone tablets and a repair kit. Or do we want the Ventura, which has radiation? I think we want something with radiation shielding panels. That's my guess. Anti-fainting. I don't know how that happens. Aurora. This one has a fuel cell. And midodrine, which is useful to prevent fainting because it works to constrict the blood vessels, thereby increasing blood pressure. And you'd faint if you just weren't getting enough blood to each one of your cells. This one kind of seems like it's the best of all things. I kind of want the Aurora. But this one seems not bad either. Gravity assist suit, repair kit, also radiation, the Reclaimer. Okay, go ahead and choose why. We chose that one. And then you're all done. That's the end of this lesson. Oh, kind of interesting. You can go into more details and you can read more about it. This one uses far more gasoline and is quite slow. If we want to move fast through space, maybe that would decrease our amount of radiation that we're exposed to. So let's see if there's a better one. Let's see. Let's go back. Maybe this Reclaimer is better. Let's go to the details. Reclaimer has earned its title as the heart of the Infinity Space Center. Although a lot of hours were used to construct this Goliath, a lot of equipment is yet to be tested. Okay, so maybe this is like the cutting edge. Maybe I'll select this one instead. Seems like it's a good thing. And then go ahead and write your reasons there. I have a dog in my lap, so it's hard to type. And oh, they're going to want you to provide more justification. But that's that. That's cool. So, interesting things all around. Okay, and so 2 more rabbit holes for you. That was pretty much the lesson. But, okay, so the last coronal mass ejection was called the Carrington Event, and it happened in 1859, so that was quite a while ago. But what happens here is the sun actually ejects some electromagnetic radiation. It shoots its way and creates what's called a solar superstorm, or geomagnetic storming, it's also called. But that ejection of radiation hits our magnetosphere and can cause disturbances there, affecting, back in the day, it affected telegraphs. But imagine what that would affect nowadays. They predict that it would actually wipe out the whole energy grid. And it forms really beautiful things like the aurora borealis or the northern lights, which is that ionization comes in, charges particles up. So if you think of a charged particle as a cation or an anion with a positive or negative charge, those emit or excite electrons, which then glow and show this glowing event. I guess the one back in 1859 was so bright that people could read by the lights, by the northern lights, which is pretty cool. All right, we'll wrap it up there. I'm not going to go into this other I could go down this other rabbit hole, but there was an interesting radiation testing event out at the Marshall Islands post-World War II, where they had an atomic bomb go off. And, connecting this back to our lesson about bioethics, they did not have the consent of the people on the island, nor did they inform them they were doing this before going in and basically testing the effects of radiation. And it causes terrible burns and radiation poisoning and cancer, like we talked about. Whole terrible things. So anyway, I know this is kind of maybe a more depressing lesson, but something to think about, the effects of radiation in our life. All right, good job today, and I will see you guys on Friday for our live lesson. We'll start thinking about ways to experiment with your body. Well, I guess the other connection is like those people where that experiment was being run, they felt like guinea pigs because they were not told of this and were used for a great experiment. So the experiment that you're going to do on your body, you have your own full consent, and you're only going to experiment on yourself. That is very important. But we'll talk more and develop those ideas on Friday. I'm going to go order my my poo kit to measure the microbiome of my gut. And that is going to be my experiment before and after sugar. So, I hope to see you guys on Friday. It's been a great little Monday morning getting these lessons out to you, learning a lot. Let me know if you have any questions. I'm going to start grading your Blue Planet reports. So, good job on those. And if you want to do the alternate lesson, the project drawdown, and research 3 solutions to climate change, I highly suggest doing that. That's a cool project as well. Take a video of yourself, just kind of like I'm doing, giving your presentation, where you can like toggle back and forth between yourself and your screen, and post that to the Wonderman site. All right. Hasta the flip side. We'll see you on the flip side, on the other side of this week.